Hi, in this lecture video, I will do a very quick introduction to the alkane functional group. So alkane refers to open chain of hydrocarbon that consists of only carbon and hydrogen on it. An alkane can be straight or branches, or can also be cyclic as well. But one very important description of alkane that we all need to keep in mind is that all of the carbons need to be single bonded with each other. They cannot be double or triple bond, because if they are double and triple bond, they would no longer be alkanes anymore, but they will be alkene and alkyne. And again, we'll learn about alkene and alkyne later. And again, in the case of alkane, all of the carbon need to be single bonded with each other. An alkane can be cyclic or acyclic. So the general formula of a acyclic alkane would be Cn, where n is the number of carbon. And now as for the number of hydrogen, the number of hydrogen would then equal to 2 times the number of carbon plus 2. And the reason why is because if we were to be looking at this example right here, this carbon right here have 2 hydrogen on it. And same thing here with this carbon. So the internal carbon will have 2 hydrogen bonded to it. And now it has 2 N to it. So in this case right here, the terminal carbon have 3 hydrogen on it, or an extra hydrogen on each of it compared to the carbon, to the internal carbon. So therefore we have to add 2 to the number of hydrogen on the 2 end of it, and thus it equal to this formula. Versus for the cyclic alkane, its general formula would be Cn, and now as for the number of hydrogen, it would then equal to 2n, and we do not see that plus 2, and the reason why is because of the ring structure. There's no carbons that actually will be having that 2 additional hydrogens. So that will be the general formula of cyclic and acyclic alkane. And each of the carbon atom within the hydrocarbon structure can be classified as primary, secondary, or tertiary, or quaternary, depending on the number of all the carbon that they're connected to. For an example, when we look at this carbon right here, this carbon right here will be classified to be primary. And the reason is in the structure, it is connected to one other carbon over here. So therefore, it is classified to be primary. The carbon, this carbon number 2, this is considered to be secondary. And the reason is because it is connected to 2 other carbon, one carbon on the left and the other one on the right. So therefore, this is classified to be a secondary carbon. And as for this carbon right here, this will then be a tertiary carbon. And this one is again will be the primary carbon. And this one will be secondary. And this carbon right here will then be the quaternary carbon, because it's connected to 1, 2, 3, 4 other carbon. So that's how the carbon can be classified. And one important thing to take notice in all of this is that all of the carbon in alkane are all sp3 hybridized. All carbon are sp3. So that is one very, very important description to keep in mind in the case of alkane. And that for physical property, alkanes have low boiling point, low melting point, low density, low solubility in water, and low chemical reactivity. So I refer to this as 5 low to keep, so we can remember they have low physical property. And the reason why is because alkane, being a hydrocarbon, they are nonpolar. So this is why they have low solubility in water, because they're nonpolar. And because they do not have any other types of intermolecular force rather than the dispersion force. So the molecules are weakly held together, and that's why they have low melting point, low boiling point, low density. And so, but as the number of carbon increases, then that when the London dispersion force can increase significantly. And this is why that in bigger hydrocarbon, they can now have much higher boiling point. So for the most part, for hydrocarbon that has anywhere between 1 to 5 carbon, they would primarily exist in the gaseous state at room temperature. Versus hydrocarbon from C6 to C17, they tend to adopt the liquid state at room temperature, with the density equal to about 0.6 to about 0.8 gram per milliliter. And if they have 17 carbon or 18 carbon or more, this is when they tend to adopt the solid physical state at room temperature. And this is when the density is about 0.8 gram per milliliter. An alkane has a lot of constitutional isomers. And constitutional isomers are basically molecules with the same molecular formula, but have different connectivity of the atom. And they are basically different molecules. So constitutional isomers are different molecules with the same chemical formula. And here is the number of possible isomer or constitutional isomer dependent on the number of carbon that exists in the hydrocarbon. So we can see that the minute we have 4 carbon or more, then the number of isomers that are possible due to the connectivity of the atom will now be increasing significantly. For example, if we're looking at a hydrocarbon with a chemical formula of C5H12, so in this case right here, this is a C5. We will then see that it has 3 possible isomers or constitutional isomers, because there will be 3 different ways how the carbon can be bonded with each other. So in this case, they can all be linear, and they can have with this particular branching right here and this particular branching. So in this case, this is called N-pentane. N-pentane, N here stands for normal. So basically, this is when all of the carbon are single bonded with each other and have no branching on it. Versus this particular pattern right here, that again, 5 carbon altogether, this is called isopentane. So whenever the one of the ends split out in this way, then that is be named as iso. And now overall, there are 5 carbon. So that's why this is called isopentane. So due to this equal splitting right here. And as for this one, again, there's a 5 carbon, and this particular splitting or branching right here is in term neo. And now it's all 5 carbon, so therefore this is called neopentane. So neopentane will refer to this particular branching right here on the hydrocarbon. And we can then see that each of these different types of pentane right here have very different boiling point and different density, because they are basically different substances. Now, as you can see, they can be different a little bit. But as for the density, then again, they can vary, but then not as much. But however, they do have different physical property. Small, but different physical properties.